Good morning, guys. We are moving into Chapter 8. Chapter 8 is all about graphing quadratic equations. So let's get going. So as I said, Chapter 8, all about graphing quadratic equations. We're going to look at the most basic type of quadratic equations today. We're going to skip the exploration. Core concept here. There's a lot on here, so let's go step by step. So the parent function of a quadratic is f of x equals x squared. That's the most basic type of quadratic equation that you can see. The graphs of all the other quadratic functions are transformations of that graph. And we've talked about the name of it before. We know that the name of a quadratic equation or quadratic function when you graph it is called a parabola. So anytime you hear that word parabola, right here, you know that we're talking about a quadratic equation. Okay? The lowest point on a parabola that opens up or the highest point on a parabola that opens down is the vertex. So this point right here, either the minimum point or the maximum point, that's what's called the vertex. The vertex of the graph f of x equals x squared, our parent function, is at 0, 0. Okay? Now we also have this thing called the axis of symmetry. The axis of symmetry is an imaginary vertical line that divides the parabola into two symmetric parts because parabolas are symmetric. Okay, and that's referred to as the axis of symmetry. The axis of symmetry goes through the vertex. Okay, and for this graph, the axis of symmetry is a line, is x equals 0. So the axis of symmetry is a line, the vertex is a point. This parent function has a vertex of 0, 0. Considering the graph of the quadratic function, using the graph, you can identify the characteristics such as the vertex, the axis of symmetry, and the behavior as shown. So we can see this graph right here. You'll notice the vertex, our minimum point, is at -1, -2. The axis of symmetry is a line at x equals -1. You'll notice that the axis of symmetry's equation of the line is the same x value as the vertex here. Domain for all parabolas is going to be all real numbers. Okay? The range, remember, domain is your set of x values. So you're saying what x values can it take on? The range is the y values. So we're saying what y values can it take on? Okay, and our range here, it never gets below -2. So our range can be written as y is greater than or equal to -2. Okay, because our range is all values when our y is greater than -2. It never gets below -2 in terms of the y. And the final thing we're looking at here is, well, when x is doing something, what's happening to our y value? Okay, so from here to here, let me highlight it. In this portion of the graph here, x is increasing, okay? And our y value is decreasing. Our graph is going down. And then in this part of the graph, here, the function is increasing. So our x is increasing from greater than 0, and the y is going up. Okay, so it's important to know when the graph is increasing and decreasing. So it's decreasing all the way to 0 in our x values, and then once we get past 0, then the function starts to increase again. So let's identify some characteristics of the graph here. First, let's identify what the vertex is. So we know our vertex is a point. It's right there. So we know our vertex is going to be at 2, -3. We know our axis of symmetry, which I'm going to abbreviate as AOS, is an imaginary line that cuts through here. And our axis of symmetry is going to be x equals, because it's a vertical line, 2. Remember, the x value of your vertex and your axis of symmetry have to be the same, because the axis of symmetry goes through the vertex. What else do we know? We know the domain is all real numbers. And we can figure out the range as well. It never gets below -3, and it's everything above -3. So my range would be y is greater than or equal to -3. We can also see that the graph is decreasing till it gets to an x value of 2, and then it begins to increase after that. Let's look at our next graph. Now notice this parabola is flipped. That's fine. Okay, we can still identify the vertex, which in this case is a maximum point, and it's going to be at -3, 7. We know our axis of symmetry is going to be at x equals -3. We know our domain is always all real numbers. And our range, now, this is a little bit different because our range is going to be y is less than or equal to 7 here, because it never gets above 7. It never goes up in this region over here. It's all below 7. And again, we can see that our y values are increasing till we get to -3 in my x, and then they begin to decrease as well. All right, so let's see how this A affects things. And this goes back to something that we saw, transformations. We get them kind of with absolute value, but some of that stuff's going to hold true here. So when your number in front of x squared is from 0 to 1, okay, that's what's called a vertical shrink. All right, what does that mean? It means that the graph is going to become wider than the parent function. When your a value is greater than 1, that's called a vertical stretch, which means your parabola is going to become narrower. And you can see that in the demonstration here. The blue graph is our parent function. When a is greater than 1, notice that's the black one, that's narrower. And when a is between 0 and 1, meaning it's a fraction, that becomes the wider graph there. What about negatives? Well, they kind of go about the same way. When you have a negative, you're going to have a reflection. So when your a value becomes negative, okay, you're going to have a reflection. And you can also have those vertical shrinks and those vertical stretches, and they follow the same thing as well. So let's compare the graphs. And we've shown you here the Desmos of these. So Desmos is going to be very important to use here. So use Desmos to help you graph. Okay, this is a Desmos screenshot here with the parent function in blue. I'm sorry, the parent function here, and then our new function y equals 2x squared. So one thing you could do to help you is to fill out a table, okay? I'm just going to pick some x values, and it's always a good idea to pick some positive and some negative. So if I plug in -1 for x into my equation, -1 squared is just 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So this graph is counting up by halves. So this is really 1. This is -1. This would be 3. So I can see that my parent function, 1, 1, 2, 4, is my red graph. So that's y equals x squared. And then my inside function, which I should know because my a value is 2, so I'm going to get a narrower graph, is y equals 2x squared. So if I pick some values here, I'll pick the same ones. Remember, order of operations, so do the -1 squared, which is 1, then multiplied by 2. So it's going to be 2, 0, 2, and then 2 squared is 4 times 2 is 8. So that'll be my new graph there. Okay, so what's different about these graphs and what's the same? We know they have the same vertex at 0, 0. We know they have the same axis of symmetry at x equals 0. We know they both have the same domain of all real numbers and the same range of y is greater than 0. So what's the only thing that's different? This is a vertical stretch. Okay? My graph, my new blue graph is narrower than the old parent function. Same idea here, okay? We haven't graphed the new function, so let's take a look at and graph that. We have our parent function. I'm going to use negative 1, 0, 1, and 2 again. So I know I'm going to get 1, 0, 1, and 4. And let's take a look what happens here when I plug in these values. So again, square it first and then multiply. So negative 1 squared is 1 times negative 1/3 is going to be negative 1/3. This is going to be 0, negative 1/3. And then 2 squared is 4. 4 times negative 1/3 is negative 4/3. So let's take a look and graph this. Now I know it's symmetric, so I know I can make points on either side also. And this will be about here. And about here. So a couple things I can see here. Again, it's the same vertex and it's the same axis of symmetry. Your range is going to be different. So your range here is y is less than or equal to 0. And your range for your parent function is y is greater than or equal to 0. Domains are the same. This would be a vertical stretch. Oops, sorry, not a stretch, a shrink this time. As well as a reflection, because we flipped our graph. And again, you could use Desmos to help you graph. We're not going to look at these. Graphing these functions, guys, how should we go about doing them? What's shown here on each of these is the parent function. These are not the graphs, okay? These are the parent functions. This is your y equals x squared parent function, okay? This is the parent function. You're asked to graph these. Easiest way to graph, make a table with x and y values. And again, good idea to pick some negatives and some positives when you're doing this. So if we plug in negative 2 squared is 4. 4 times 5 is 20. 5, 0, 5, and 20. So our new graph, which I'll do in blue, 0, 0, 1, 5 is not even on the graph. It'd be way up here. Same thing here. So you'll see this has become a really narrow graph. And again, you would go through the same process of comparing domain, range, and so on and so forth. So when you're asked to graph it, use Desmos, make a table, and then compare in the same exact way that we were doing before. It's just practice. That's all it is to it. Make sure you know the basics of it, and you should be good to go. That's it, guys. See ya.